A 25 by 25 by 10 centimeter block of iron floats on mercury. If one of the 25 by 25 centimeter faces is down into the mercury, how far into the mercury does the block sink before coming to equilibrium? Well, it's got to displace a mass equal to, it's got to displace a mass of mercury that's equal to its own mass, right? So there's two ways to do this, right? I'll show you the way you're supposed to do it, and then I'll show you a quick and dirty way. Let's figure out, so to float, right, the mass displaced has to equal the mass of the object. Okay, mass displaced equals the mass of the object. I know this looks like two mo's, but there we go, right? Okay, so the mass displaced, let's figure out the mass of the object first. That's easier, right? So the mass of the object is just going to be the density of the object times the volume of the object. And it's made of iron, so it's 7,800 kilograms per cubic meter, and then its volume is 0.25 times 0.25 times 0.10. Okay, so 7,800 times 0.25 times 0.25 times 0.1. So it has a mass, it's decently massive, 48.75 kilograms. So to float, it must displace that much volume, right? So let's figure out what that volume is. So it has to displace this many kilograms of mercury to float. That's the rule, right? To float, you displace an equal mass to your own mass, right? So now let's figure out the volume of the mercury, okay? That's going to be the mass displaced divided by the density of the mercury, right? So the mass, this is mass displaced, which is that same mass, right? So that's going to be 48.75 divided by 13.6 times 10 to the third. So divided by 13600. And we're going to have to displace 0.0035845, et cetera, cubic meters of mercury, right? Okay, so now this block is going to sink in, right? Some amount, it's going to sink in, and we'll call this distance x, right? And that the volume is going to be, the volume of the object is going to be 0.25 times 0.25 times x, where x is how far into the stuff it sinks, right? And that's going to equal this volume, right? So that's going to equal 0.25 times 0.25 times x. So I can just divide my answer on my calculator by 0.25 squared. And I get that x is equal to 0.05735 meters, right? This is the right answer, right? Now, you're asking yourself, gee, this is a lot of steps. Is there an easier way to do this? And remember, that distance is to the total distance, which is 10, right? The 10 could sink in 10, right? As the density of the object is the density of the fluid. Try it. We'll go 10 times divided by 13,600. Hey, I got 5. I got x is equal to 5.735 centimeters, right? So that's always true, right? This thing, if it's half as dense as mercury, it's going to sink half of it in there. If it's 1/4 as dense as mercury, 1/4 of it will sink in there. If it's 9/10 as dense as mercury, it'll sink 9/10 of its dimension into the mercury. Okay, so just remember the shortcuts.